All right, welcome to the Explainer. You ever wonder how your phone can just magically find every picture of your dog when you type in the word dog? Or what about how those AI chatbots seem to know stuff that's definitely not on the public internet? Well, the answer to both is this really powerful technology called a vector database, and today we're going to break down exactly how they work.
So you know that old saying, right? A picture is worth 1,000 words. I mean, just look at this mountain sunset. We get it instantly. We see beauty, nature, this feeling of calm. But a computer? How does a computer understand any of that? How can it possibly grasp the actual meaning behind all those pixels?
Well, if you try to store this image in a traditional old-school database, you're going to hit a wall fast. I mean, sure, you can save the file name, the date it was taken, maybe even add a few manual tags like sunset or orange, but come on, that barely scratches the surface. It completely misses what the picture is about, its whole semantic context.
And this right here, this disconnect between how we see the world and how a computer just stores raw data, well, that leads us straight to the core problem that vector databases were designed to solve. It's got a name, actually, the semantic gap.
Okay, so this really just lays it all out, doesn't it? On one hand, the computer sees structured, factual data. But on the other hand, we see nuance, feeling, complex ideas. I mean, think about it. How could you possibly ask a computer to find images with a calm mood when all it knows are file names and a couple of basic tags? The short answer is, you can't. So the formal name for this problem, like we said, is the semantic gap. It's this huge chasm between just storing raw data and actually having a true understanding of it. You know, traditional databases are amazing at finding exact matches, like findme filename.jpg. But they really fall short when you ask them to interpret meaning.
So the big question is, how do we bridge that gap? And that, right there, is where our topic for today comes in. We need a totally new way of thinking about storing and finding data. We need a new kind of database.
See, vector databases work by organizing information based on its semantic meaning, what it's actually about. It's kind of like a library that organizes its books by plot and theme, not just by the title on the spine or the color of the cover. It understands the content inside.
And here's the cool part. This approach isn't just for photos. It works on almost any kind of unstructured data. You know, the messy stuff that doesn't fit neatly into spreadsheets, like articles, audio clips from podcasts, even video. Basically, if it has meaning, you can turn it into a vector.
Okay, so how on earth does a database understand something as abstract as meaning? It's a great question. Well, it doesn't use words. It uses math. It translates all these complex concepts into a mathematical language. It's basically teaching the computer to speak in numbers.
The magic trick behind all of this is something called a vector embedding. The easiest way to think about it is like a numerical fingerprint. It's just a long list of numbers that represents the core essence of, well, anything. And here's the most important part to remember. Things with similar meanings will have very similar numerical fingerprints. So let's jump back to our mountain sunset picture. A really simplified embedding for this image might give it a super high score, like 0.91, for significant elevation. Makes sense, right? And then a really low score for urban elements, and another high one for strong, warm colors. It's literally converting the ideas in the picture into a list of numbers.
Okay, but what about a different but kind of similar image? Let's say a sunset at the beach. Well, its embedding would look a little different. It'd get a really low score for elevation, obviously, but a really high score for those warm colors, just like our mountain photo did.
And now, when you put these two vectors side by side, this is where the magic really happens. You can see their scores for strong, warm colors are incredibly close, but their scores for elevation are worlds apart. So just by measuring the mathematical distance between these two numerical fingerprints, a computer can understand that, hey, these are both sunsets, but one is in the mountains and the other one isn't. In the world of vectors, proximity is similarity. That's the key. Now you might be wondering, who's creating these numerical fingerprints? Well, they're definitely not made by hand. They're generated by a specialized kind of AI called an embedding model. You just feed data into it. Images, text, whatever, and it crunches through it all and spits out these powerful numerical representations. And of course, there are different models for different kinds of data, like clip for images or glow for text. All right, so we've turned millions of images and documents into millions of these super complex vectors. That's great, but this creates a whole new challenge. How in the world do you search through all of them in the blink of an eye? It's the classic finding a needle in a haystack problem, but on a massive scale. And the scale we're talking about here is just mind-boggling.
This isn't a few thousand items. We're talking about modern vector databases that can hold hundreds of millions, sometimes even billions, of these complex fingerprints. There's no way you can just check them one by one. It's impossible.
So that leads to the, well, billion-dollar question, right? How do you find the closest match instantly without having to check it against every single other vector in the database? Just brute forcing it would be way, way too slow to ever be useful.
The solution is actually a really brilliant compromise. See, developers realize that finding the absolute 100% perfect match takes forever. But finding a bunch of almost perfect matches, that's lightning fast. And this super clever shortcut is called Approximate Nearest Neighbor Search, or ANN for short. You're basically trading a tiny, tiny bit of accuracy for a massive jump in speed.
Okay, and now we get to the part where this all really comes together. Why this matters so much right now. This ability to search for meaning at incredible speeds isn't just some neat party trick. No, it's a foundational piece of the puzzle for the most advanced AI systems being built today. Let's dig into how it's powering modern AI.
So vector databases are the engine behind a super powerful technique called Retrieval-Augmented Generation, or just RAG. This is the secret sauce that lets large language models, the brains behind chatbots, access information that's external or private or totally up to the minute to answer your questions. So here's how RAG works, step by step. First, you ask a question. Then, the system instantly searches its vector database for any information chunks that seem relevant. It finds those chunks, and then it feeds them to the language model right along with your original question. And what you get back is an answer that isn't just pulled out of thin air. It's actually grounded in real, specific data.
So when you boil it all down, a vector database isn't just a place to dump data. Not at all. It's a living, dynamic system for storing information and, even more importantly, for pulling it back out fast, based on what it actually means.
So, by translating our world into numbers, we've actually started to bridge that semantic gap. We've built databases that really do understand that a beautiful sunset is way more than just a bunch of orange pixels. And that leaves us with a pretty big thought to chew on. We've taught machines to grasp the meaning of a picture. What happens when they can fully grasp the meaning behind our words, our questions, and even our intentions?